Hello, warm welcome to everyone. Thanks for joining this Prevail session. So in this session, so this is second session in the series. So in first session, we talked about theory, what is Selenium, what is functional test automation, how Selenium helps to automate your web application testing, what are the basic Selenium commands, what are the locators, what are the different frameworks. We talked about two frameworks. One is UIF, and another one is IBM Ignite OTFA. And then we had one couple of slides about what is Docker, what is OpenShift and all, right? So in this particular session, which is kind of follow up to that previous session, we are going to explain how you deploy the functional test automation framework in the OCP platform, OpenShift container platform. Okay. So, so for this deployment purpose, we have kind of created one web-based framework, which is called as UIF, User Interface for Automation Framework. So it's a scriptless framework. We'll talk in detail about that one in upcoming slides. And then we'll probably just talk about the framework and how do we deploy it. Okay. So myself, Praveen from Global Test Automation team. So I work as a test automation consultant and specialist on this team. And then I have with me my colleague Bharat, who is the application developer who kind of developed the framework from backend perspective, front end perspective, and then he's also kind of helping to explain about OpenShift, how it is getting deployed, what are the different configuration we have to do. So all the cloud details and everything he will be explaining along with me in this session. Okay. So let's start. So for this particular session, the agenda is basically we are going to talk about UIF framework. So we did touch base on this framework briefly in our previous session also, but I will still reiterate that because we are going to use that framework throughout this session from deployment perspective. And of course, in the upcoming session also, which is going to be hands-on exercise. Okay. So we'll talk about UIF framework. Okay, then we'll talk about what is the flow of execution, right? How the flow is there for executing the test case through the UIF framework. Then Bharat will kind of explain some of the technical details about the framework from front end, back end, what are the technologies used from different component perspective, what are the open source libraries, components, separate files are used. So he will explain all those details. And then Bharat will be explaining some of the configuration details also. Okay. So from both configuration files perspective as well as service perspective also, what are the things we will be doing. So he'll be explaining that in detail. And then finally, we'll just talk about deployment order in the OpenShift because we will have multiple YAML files. So we'll be just explaining about what is the sequence you need to deploy these YAML files to OpenShift platform when you do the hands-on exercise. Okay. So that is pretty much going to be the agenda for this session. Okay. So let's start without wasting much time. Okay. So let's start. So first here you see about what is UIF. So as I mentioned earlier, UIF is a scriptless test automation framework, which is going to help you to create your test automation without doing any descriptive programming, right? Because sometimes that becomes bottleneck, right? You might not have the right skills or resources who knows the programming to help you create your test automation. That's why we have kind of built this framework in a scriptless manner, which can be easily learned by a non-technical person and can be used for execution or creating automation. Okay. It is kind of following the hybrid approach. It kind of uses some of the like a data-driven, keyword-driven approach also. So that's why we call it as a hybrid approach framework. Okay. Again, it's built on top of Selenium, right? So that's the core engine, which is used to execute your web application testing, functional test automation. Okay. And again, it has some built-in integrations with Jenkins, CI/CD tool and test management tools also. Okay. So that also we can explore basically. Okay. So some of the additional features for the framework is like it's very simple to learn. Okay, it's pretty much straightforward, easy to learn, navigate through the screens. So that's why we call it like the learning curve is very sharp, right? The new people, non-technical people also can get on with the framework quickly and start using it. Okay, within just a few days of time. Okay, we talked about it's a scriptless framework, so no dependency on programming or scripting language knowledge. Okay, it kind of is based on the record and playback. And in the upcoming session, when we explain about hands-on, you will see what does record and playback mean, right? So it basically you just record your actions and then you just replicate or play those actions back after some configuration changes or based on your need. Okay, so that's why it's based on the record and playback mechanism. And it has a lot of industry standard tool integration already in build like Jenkins. We can explore multiple reports, basically reporting formats. We can use some of the email advanced functions also, auto email trigger and other things. We can also use integration with some of the test and defect management tools like ALM or Jira. Okay. And again, all these are based on the open source tools and library. So it means there is a lot of potential to customize it based on the need in future. Okay. Again, it's easy to maintain test automation framework that can be used across teams, right? Uh, uh, and as I said, it's very simple to learn, right? So anybody can start automating it quickly using the framework. Yeah. So how does the flow of execution work in this framework? This particular slide basically just depict that picture. How does it work? So basically, once you open the application and once you launch it, you have an option to register yourself if you are new user, or if you are already registered user, then you can just log in yourself, right? Once you log into the application, the framework, then you first thing you need to do is like you need to have your own project, or you need to have some access to the project where you want to execute your test cases, right? So you are basically creating a project. Under that project, you can create multiple test cases, right? So you may have like a multiple test cases as a part of your project or test suite, right? So all those test cases has to be added or mapped to that particular project. And then with each test case, there will be two files basically what we need to upload. One is like a script file, which is going to include step-by-step instruction or actions about your framework, how the test case is going to be executed. That file is going to have another tab with the object locator properties. And in our previous session, we talked about different Selenium locators and all, right? So all those locator repository will be maintained in that script file. Okay. There will be second file for each test case, which will be the data file. So the data file is going to include all your test data, basically, what will be used for execution. Okay. So for each test case, these two files will be mandatory to upload. So once you upload these two files, you will be ready to execute your test case, right? So you can trigger, let's say, two parallel test cases also for execution, and automatically the test cases will start to execute with the help of Selenium Grid, okay, on a remote server. And in our previous session, we talked about Selenium Grid also, right? So for UIF and for this OpenShift deployment framework, we are leveraging the Selenium Grid to do the actual execution, okay? And then once the execution of test cases is done, you basically can see the project reports. There are multiple format of reports. You can download Excel report, you can download Word report with screenshots and status. And then you get on the dashboard itself, you get a simple pie chart view also with pass, fail, not run test, not executed test cases. And then you will have an option or link to directly go to the result also on the report, where you can directly see the all the details. If something is failed, you can see the error logs. If everything is passed and all, you can directly see the screenshots also from that report page. Okay, and then you will have option to upload the results in Jira or ALM also based on your need. Okay, so that will be like a full flow of execution. Uh, we will talk about how do we create the test Excel files basically in the hands-on session. But right now, from a functional test automation framework or tool perspective, this is going to be the flow of execution what tool will support. So tool is going to support you support you to maintain your existing test cases. Like if you want to do any modification of steps and all or data, you can manipulate data and upload those files, like maintain those files or test cases, and then it will help you to execute those test cases also, right? Creation part we will see in the upcoming hands-on session on day 2 of this workshop. Okay. So this is going to be the flow of execution. So with this, I would like to hand over to Bharat, who will explain you about some of the technical details about what are the things we are using for this framework and how the different configuration files will be done and how they will be deployed to the OpenShift environment. So
Yeah.
over to you, Bharat. Uh,
Hi all. So uh, Praveen has explained about the execution flow. So it's just an overview of the framework. Now I'll explain about the technical diagram. So as you can see, we have used for the front end React.js and backend it is done with the Django. And we have used Nginx as the web server. So all the requests you made through the browser will come through the Nginx, and if those are static files, it will go to the front end, and if it is API related, it will be sent to the Django framework. So this is hosted as a separate pod, and Nginx is also a separate pod. And we have used RabbitMQ as a message broker and PostgreSQL CouchDB as a database. I'll come back to this slide after explaining each component. So let me move to the next slide and explain about each components in detail. Then we'll come back to this slide. So Nginx. Nginx is a web server that can act as a reverse proxy or email proxy or a load balancer. In our case, we are using Nginx to serve the front-end application, also the static and media files generated by Django. The reason why we are using Nginx here is because uh, usually Django is a Python-based open source web application. It cannot, for it to connect with the outside world, it need to have a WSGI server, a gateway interface. Okay, it's called a WSGI server to interpret and handle the request to Python. So in our case, we are using a Waitress as a WSGI server. You have other options like a Gonic New WSGI, etc. Here we have used Waitress, so which will act as a WSGI server. So Nginx is in front of it. So all the requests coming to the Django application will be passed through the Nginx, and it will decide where it will go. If it is to the static contents, it will serve the static contents. And if it is to the front end files, Nginx will serve it. If it is meant for the backend, it will route it to the uh, Waitress WSGI server, which is running behind. Next, Django. Django is a Python-based open source web framework, and it uses the MVT architecture, which is nothing but model, view, template. So we have a model where all our business logics and DB schema are defined, and a view where it decides what to show to the user, and our logics are implemented there. And the template is nothing but the HTML files which users see. Those are called templates. So it is a MVT pattern, and we have written using Django, and the APIs are created using Django REST framework. Now next component is Celery. So Celery is nothing but a task queue, which is a data structure maintained by the job scheduler for running the jobs. And basically it is used for asynchronous operations. So it will be executed in a non-blocking way. Let's say you have a long running task, and we cannot hold that request for a long time. We need to send the response instantly. So in that case, we send that request to Celery, and Celery will handle it so that the user can get the response immediately. But behind the scene, that execution will be carried out by Celery. and RabbitMQ. So Celery is used in combination with the RabbitMQ. It's a message broker. It acts as a intermediary for messaging. It gives your application a common platform to send and receive messages. So it allows the applications or services or system to communicate and exchange information between each other. Then two DBs, one is PostgreSQL and CouchDB. So PostgreSQL is a relational database and it uses the table-based format to store the data. So all the models, in the sense like in the UF application, you are creating the projects, test cases, all those data are stored in Postgres in our framework. And the files which you are uploading, your uh, test data file, script file, and the reports, those we are storing in the CouchDB. CouchDB is nothing but a document-oriented NoSQL database. So basically, it stores the data in key value pair or a white column or document-based format. Now let me go back to the technical slide. So I'll explain with the flow here. So assume the user makes a request. Okay, so first Nginx will serve the front-end files, the basic HTML files it will serve, all the static contents. Now you are making a request to the backend. Let's say you are creating a project. So that request will be sent to Django. And here in Django, we are running a Celery as well. So those requests which won't take much time, like creating a project or creating a test case, those are non-time taking tasks. So that will be handled by the REST API and you will get the response instantly. Now, you have created 5 test cases and you are you are you have clicked on the execution button. Now what will happen? Your test cases are lengthy and it is time consuming task. You are executing 5 tasks, 5 executions, which will take around like 15 minutes, let's assume. So we don't want the user to wait for that 15 minutes. We want them to allow uh, navigating to other pages or doing the next execution, etc. So we cannot hold them for that request. We need to send the response instantly. In that case, what we are doing, that request will be sent to the Django, and that time taking task, it will be sent to Celery, and Django will send a response instantly saying, yeah, we have received your request and we will be processing it in this much time. So you'll get a response back instantly. And that task, we call it a task here, that execution, the execution of 5 test cases. So that task, Celery will publish it to a message broker. As I have explained, it is nothing but a system where it can share information between two systems. It's a platform for sharing messages between services or applications. So Celery will publish it to RabbitMQ. So first request you click on execute for 5 test cases that will be published to the message broker. Next, another user also does the same operation that will also be published to the message broker. Now this Celery has multiple nodes. Okay, it's called worker nodes. So in our case, we have set it like 20 nodes. So what it will do, these nodes will subscribe from this message broker. All these tasks, all the requests, it will again fetch back from the RabbitMQ. Those worker nodes will fetch it and it will start to execute. As Praveen mentioned, your execution happens on the Selenium grid. So here in the backend, these worker nodes will fetch the message from RabbitMQ. It will do the DB hits and it will get your test data or script files, whatever it will get, and it will give that request to the Selenium hub. So your execution happens there, and Celery keeps a track of that execution. So once that execution is completed, that task will be marked as finished or succeeded. If it fails, it will be marked as failed. So always from the front end, you can query the execution status. We have an option for that. So you can go to a page and you can check what is the status of your execution. So you will get to see whether it is in the pending status or it is executing or has it finished. You'll get all this data in the front end. Now, yeah, these are the DBs where we store our data. So this is how the a tech stack for our UF web application. Now, yeah, let me go to the deployments. So these are the configurations file we have created. We have some configurations file to deploy for the OpenShift. So all these components which you have seen, Nginx, Celery, Django, PostgreSQL, CouchDB, RabbitMQ, these all are single components. We have to create a pod for all these components. So for creating the pods, we need two things. One is a deployment file and one is a service file. So every component will have a deployment and a service file in our case. Okay. So here, this is an example of a configuration file. Okay. On the left side, you are seeing the deployment file, and on the right side, it is the service file. It's the configuration files. Okay. We need these two to deploy the service. Now, let me go through the configuration files and explain what in each fields mean. So, yeah, you can see it's logically structured, and the format will be YAML, YAML, YAML format, and it's pretty straightforward to understand. But one thing, it's very strict about the indentation. You cannot have wrong indentations, it will throw error. So it should be indented properly. Now, yeah, here as you can see, these first two lines, API version and kind. So this declares what you want to create. So on the left side, what you're seeing here, it means we are creating a deployment. Okay, here we are on the right side, we are creating a service. So it declares what you want to create, and yeah, and that's it. Now, every configuration file, it has three parts. One, metadata. So you can see both the files have a metadata, and one of the metadata is a name and a label. Second one is specification. Okay. So this is where basically you put in all your configurations that you want to apply for the component. So here you can see replicas, how many pods you want to yeah, how many pods you want to create and selectors, etc. So that's what you put in the specification. I'll come back to it later. So yeah, that's it. That's where your configuration for the component is defined. And the attributes will be specific to the kind of the deployment. So here, these attributes, replica, selector, this uh, specification, it's specific to this deployment file. Okay, and this specification, it's specific to this service configuration. Now, the third part, you won't see it in the deployment configuration now, but when you deploy it in, that will appear. Uh, that third part is status. Okay, so that will be automatically generated and created by the Kubernetes. So when you deploy, it will be automatically generated by the Kubernetes. So the way it works is that uh, Kubernetes will always compare what is desired state and what is the actual state. Here you can say this replica is equals to 2. That's your desired state. Here replica is equal to 2. So which means you want to run two pods. Let's assume you want to run two pods. So that's your desired state. But when you're deploying, it's actually running one pod. So your desired state is not matching with the actual state. So in that case, Kubernetes will fix it. So it's actually, so this is what the self-healing feature that Kubernetes provides. So now we will have a question. So from where Kubernetes will get this data? It will get this data from something called HCD. So it's a distributed key value store for storing all these metadata or specifications. So it's stored in the HCD, and Kubernetes collects all this data from there, and it compares with the actual and the desired states, and it will do the needful. It will fix if anything is wrong, or it will continue. It will regularly check for the states. Kubernetes will check for the states regularly. These deployments, let me clear it. So this deployment you see here, this is a deployment. This will manage all the pods under it. We have talked, there are 2 pods here. So this deployment will manage all these 2 pods. So whatever configurations you apply to the deployment, it will cascade down to the pods. And if you go to the template section, here you can see it also has the same attributes what you have seen for the deployment. Metadata, here also you have it. Labels, yeah, you have it here as well. Specifications, you have it here. So it's like configuration within a configuration. So these configurations apply to the pod. What you see here within this template, this configuration, it applies only to the pod. Okay, this applies only to the pod. So pod should have its own configurations inside the deployment config file. So it's like a blueprint for the pod, and it will decide like what is the name it has to give for the containers and which image it should use. So here you can see Nginx 1.16. So it will pull this image from the Docker Hub, and it will use this image. And port, it will be it will be serving on port number 8080. So this is the blueprint for the port. And now, yeah, regarding the service configuration, yeah, I'll come to it later. So the way this connection established between the pod and deployment is using the labels and selectors. So here you can see, yeah, in the template, as I said, this is for the pod. This is for the pod, and here you can see it has metadata and label. So this is a key value pair. It can be anything. Here we have given app as the key and Nginx as the value. So this deployment will connect to this pod using this label. Here you can see selector. So it will match the labels app colon nginx. So this will be get linked. So this deployment will be linked to these pods. So whatever you changes make in the deployments need to cascade down to the pods. So you have this linking. So it's using the labels and the selectors. Now, the service is responsible for enabling the network access to the pods. So this service will make sure there's a network access to your pods. Here you can see it also has a specification and it has a selector. So you can see our deployment file has a label. So in the first case, it has used a selector for matching the label with the pod. Now, this service configuration will use this selector and it will match with the deployment. So this label you can see here, app nginx, it's a key value pair. That label is used by this service. So it uses this selector for connecting between them. And ports, it uses a TCP protocol. This port will be exposed to the outside world, the host port. It will be serving your application on port number 80 to the outside world, but all the requests coming from outside, it will be sent to this target port. Target port is nothing but where your ports are running. You can see here your container port is 8080. So it just acts as an abstraction where all the requests coming to port 80 will be mapped to port 8080. It will be sent to your pods for execution and so on. Yeah. So this is just a basic configuration file. You can have a lengthy deployment or service configuration files, but it comes down to these concepts. It has three parts: metadata, specification, and status. Status, it's auto generated, so you need not to worry about it. And specification, where you may have many options like resources. What are the resources we need to allocate, the CPU or memory, etc. So yeah, that's it about the configurations file here. Now let's go to the deployment. So this deployment is for our UF application. Here we have 19 configuration files. So first one will be the declared. We cannot declare it in the application. We cannot hard code it. So you always have to externalize it. So all those data are in this YAML file. And we have a PG data and DB data. These two are persistent volumes. We have two databases, Postgres and CouchDB. Every time your pod restarts, these services, Postgres or CouchDB restarts, or if any issue happens, all the data stored in will be lost. We don't want it to happen. That's why we are mapping that into a volume. So all those data will be stored permanently in those volumes. If your pod restarts, that data won't get lost. It will be still present there. So for saving that data in such cases, we are using this persistent volume. So this is a volume claim, it's a PVC. So this volume which is created, it has to be claimed, right? So we are making a request for claiming that volume using this PVC. Okay. Next, we have this hub deployment and hub service. This is our Selenium grid. And we have Chrome deployment, Chrome service, Firefox deployment, and Firefox service. These are nodes. This Selenium grid, we are having Chrome and Firefox nodes. So these are the configuration file for that. Next, our databases. The first two were PVC, our persistent volume claim. Now these are database. We are creating the service, database service, Postgre and CouchDB. Now, after creating when you are deploying, after creating these services, you need to create a route for this DB, which I'll show in the demo. You need to add a route for that, and you need to create a database named projects in that. Then only the next deployment will work. Next, in the sense, this web and Nginx deployment, it depends upon these databases. So after that, a service is up, and after that, a DB is created, then only these two services will start to run. Okay. And this one, UF Rabbit. This is the message broker, which I have explained in the last slides. Message broker it's a platform for holding the messages. So we are deploying it here. And web deployment. Here in the web deployment, we are running the Django server, Django service, and the Celery service. So both are run together here. Then Nginx, it will sit in front of this Django server, and it will hand the request. So uh, that's uh, that's all about the slides. And thank you all. Now
Yeah,
we'll
thanks.
go for, yes, Praveen.
Yes, thanks a lot, Bharat, for explaining in detail about the framework and how we are going to use to deploy it to the OpenShift platform. So theoretically, we just wanted to explain to everyone uh, what are the different components basically and the different YAML files, what we are going to use to deploy, what is the purpose of each YAML file, and then what are the contents of YAML file. So all of that, before we go to the hands-on and the lab session, we just wanted to explain that in detail to the audience. And then the next session basically will be the explanation of deployment of this functional test automation framework to OpenShift platform. So that is something we will see in the next session. Okay, so thanks everyone for joining us today and thanks for listening in. So hopefully this will help you to know about functional test automation and how that can be deployed to the OpenShift platform theoretically, right? So in the next session, we will see the practical implementation of all these concepts uh, in the practical hands-on session. So thanks everyone for listening in and joining today.